We are trying to talk about specific attributes or characteristics of a rational function, the vertical asymptote, the horizontal asymptote, the x and y intercepts, and it's all about knowing which part of the function to look at. As you prepare for this test, please maybe get this sheet out that was given to you. It kind of tells you exactly where to look for each thing. The math involved is math that we've been working on all year, so that's not the tough part. The tough part is just knowing where to look and what to do with what you're looking at. For those vertical asymptotes, as you can see here, we're going to look at the denominator, and we're going to try to figure out what values of x make this equal 0, and that will tell us where the graph cannot cross. So I will take this 4x squared minus 25, and I will try to find the zeros of this function. This is going to factor very nicely because of all these perfect squares. There's no x term. That tells me that I can definitely use a 2x and a 2x and a 5 and a 5 and a plus and a minus. That's the difference of squares we've talked about, and setting these both equal to 0 and solving them, this would give us a value of x equals, if I subtract 5 and divide by 2, negative 5 halves. If I were to set this equal to 0, I would add 5 and divide by 2, getting a positive 5 halves. So my vertical asymptotes will be two of them. It'll be x equals 5 halves or negative 5 halves. We can write that like this. If you want full credit, you definitely need to include that x equals, not because I'm a stickler, but because it needs to be the equation of a line. And if you don't say x equals, it's not the equation of a line. So it's kind of important. For the horizontal asymptote, that's the leveling off behavior of the function. It's what happens when x gets really, very far from 0. And as we talked about, that when x is very far from 0, in each function, that lead term takes over. So we're going to just look at these lead terms and see what they simplify down to for the horizontal asymptote. 16x squared over 4x squared is something that we definitely know how to simplify. In this case, all the x's will cancel off, giving us 16 over 4, which that reduces down to 4. It's just a simple number, a single number 4. So the horizontal asymptote will be a horizontal line. So it'll be y equals, and then whatever that number happens to be. For the x-intercept, that would be anything that makes the numerator equal 0. So it's going to be a lot like finding the vertical asymptote, but we're looking at the top instead of the bottom. So take that 16x squared minus 1, set it equal to 0. And this is one that, again, easy to factor because there's no x term. There's a lot of perfect squares here, so I'll go with 4x and 4x to get the 16x squared. 1 and 1 to get the 1. 1's plus, 1's minus. That has to equal 0. If I set this equal to 0, I'll subtract 1 and divide by 4. So I'll have a negative 1/4. If I set this equal to 0, I'll add 1 and divide by 4 and get a positive 1/4. You can put the x if you want to. You don't have to, but these will be points on the x-axis. Finally, for the y-intercept, we would be plugging in 0 for all of the x values, but the end result of that is that we just have these last terms showing up. These guys that without x's on them are all that's left. So I can just focus on these last terms, look at them as if they were one single number. You know, if you have a negative over negative, make that positive. So the y-intercept would be at 1/25, which would be a very small number, very close to 0, but positive. And that'd be it. So for each of these, we're either simplifying expressions like we've done back in chapter 5, or we're solving quadratics like we did back in chapter 3, but we're needing to know where to look and what to do with what we're looking at, and it should be good. Good luck.